In this particular question, we've been given the rational function g of x, which is equal to 3x divided by x squared minus 4. And we've been asked to identify points of inflection as well as determine the intervals in which the function is concave upwards and the intervals in which the function is concave downwards. What I'm going to start by doing just off to the side is I'm going to rewrite that function in a manner such that I have factored the denominator. So g of x is going to equal 3x divided by x plus 2 times x minus 2. In this factored form in the denominator, what we can quickly recognize is that this function has two vertical asymptotes. The vertical asymptotes being at x equals negative 2 and x equals positive 2. It's important to identify vertical asymptotes because concavity can change on either side of those vertical asymptotes. The same is true as if the question had asked you to determine increasing and decreasing intervals. You would also have to consider vertical asymptotes and see if the function is changing from increasing to decreasing or the other way around. I know that wasn't asked in this question, but it's something that should be mentioned because you will encounter it in some of the questions you will obtain from the textbook. So we now know we have two vertical asymptotes. Well, the next thing we're going to do is find g prime of x. To do so, we're going to have to use the quotient rule. So in the numerator, we're going to have x squared minus 4. That's all being multiplied by 3. Subtract from that 3x times 2x. And then that's all divided by g of x squared, which in this case is x squared minus 4, all squared. In the next step, all I've done is expanded the terms in the numerator using my distributive property in the first case where I had the binomial multiplied by the monomial. So I find that g prime of x is equal to, in the numerator, 3x squared minus 12 minus 6x squared, and that's all being divided by x squared minus 4, where that x squared minus 4 is all squared. Combine my like terms in my next line. And so now I have my first derivative in the most simplified form. What I'm now going to do is take the second derivative, because I know that points of inflection occur when our second derivative is equal to 0 or when our second derivative does not exist. So again, we're going to have to use the quotient rule, and what makes this a little more challenging is embedded within that there is a chain rule question. So g double prime of x is going to equal, in the numerator we're going to have x squared minus 4 all squared times negative 6x. We subtract from that negative 3x squared minus 12, which is all multiplied by 2, which is in turn multiplied by x squared minus 4, which is in turn multiplied by 2x. And then all of that is divided by x squared minus 4, which is squared, which is in turn squared again. So in the next step, what I've done is I've looked at my terms in the numerator and I said, can I common factor anything out? Well, I can. I can common factor out a 2x and an x squared minus 4. And that leaves me within the squared brackets with an x squared minus 4 times a negative 3. Subtract from that negative 3x squared minus 12, which is multiplied by 2. And then all of that will be divided by x squared minus 4 to the 4.